we haven't recorded until now. To find the determinant, it is the difference in the cross products. So this entry times this entry minus this entry times this entry. This is our notation, either determinant, and we name the matrix, or the big absolute value bars around the matrix. So we started with 2 examples. We're going to do 4 more now. All right, so 1 times 3 is 3 minus -1 times -3 is also 3. 3 minus 3 is 0. We're going to talk about why that's special in a second. All right, this one is -9 minus -2, which is -7. This one is 3 minus 3, which is 0. This is 10 minus -10, which is 20. All right, any questions on how to find the determinant? Great. All right, now let's go back up here and talk about how to find an inverse. To find an inverse, the first thing we do is 1 over the determinant. And then it's kind of interesting. This becomes a scalar multiplication problem, and this is our scalar. So we'll switch these two. So we switch the A and the D. We switch the main diagonal, and we negate, change the signs of the other diagonal. Moby's like has a life of its own over here. Hold on, let's see if we can get it to behave. There we go. All right, so an inverse is 1 over the determinant, switch the main diagonal, negate the other diagonal. All right, so when this says tell whether the matrix has an inverse, if the determinant is 0, what happens right here? What is 1 divided by 0?
It's undefined.
It's undefined. So whenever our determinant is 0, there is no inverse. So this one has a determinant of 0. This matrix has no inverse. This one has a determinant of 0. This matrix has no inverse. Okay? So if the determinant is 0, there is no inverse. All right, now let's go ahead and use this number 1 as an example. I'm going to steal number 1. We're going to use it as an example. So we'll say that matrix A is 4, 3, 2, 1. You guys already found the determinant. It's -2. So if we find the inverse, it's 1 over the determinant, which is -2. And then what we do is we switch the main. So these two switch. The 1 comes here, the 4 goes there. And then we negate the other. So it becomes -2 and -3. Now we just have to multiply by the scalar of -1/2. So 1 times -1/2 is -1/2. -3 times -1/2 becomes a positive 3/2. -2 times -1/2 is positive 1. And then 4 times -1/2 is -2. Now, this is the last cool thing I want to talk about, and it helps us to determine if matrices are inverses. Yesterday we talked about how matrix multiplication was not commutative. In only very special cases can we switch the order in which we multiply and actually have the same resulting matrix. And this is it. When I multiply inverses, the same thing will happen every time. So I'm going to multiply these two inverses, and we'll see what happens. We know they're inverses because I just found them to be inverses. Okay, so A times A inverse. When we do this row times this column, we get -2 plus 3 is 1. We get 12 halves, so that's 6, plus -6 is 0. We get -1 plus 1 is 0. And we get 3 minus 2 is 1. We get this very special matrix when we multiply inverses. It's actually called the identity matrix. And we can have an identity matrix for any square matrix, but we're only doing 2 by 2s. we're doing the smallest square matrix. So what you'll notice is for all identity matrix, there are 1 in the diagonal and zeros everywhere else. So anytime you multiply a matrix times its inverse, this is what you get. And even if I switch the order, if I put this in front, okay, so let's say I did A inverse times A. Now yesterday we did several of these, and we never got the same thing when we switched the order. But this time we are. So if I switch the order here, and I do the -1/2 and the 1 and the 3/2 and the -2, and then I multiply A times that. So this time I'm starting with A inverse, and then I do A. I'm still going to get -2 plus 3 is 1. And then I get -3/2 and +3/2 is 0. Then I get 4, take away 4 is 0. And 3 minus 2 is 1. So look at this. A times A inverse was the identity. A inverse times A was the identity. And that's a way to prove that you have inverses. When you multiply any two matrices and we get the identity, these two are inverses of one another. Okay, now let's go back and actually find some inverses now. Well, first of all, let's determine, are these inverses? If they are inverses, the resulting matrix better be the identity, 1, 0, 0, 1. If we get anything other than that when we multiply, they are not inverses. Okay, so let's do this first one together. 3 minus 1 is, 3 minus 2 is 1. And then -2 plus 2 is 0. And then 3 minus 3 is 0. And then -2 plus 3 is 1. Are these inverses?
Yep.
Yes. Okay, you try number 8. Go ahead and multiply, and if we get the identity matrix, they are inverses. So, on this one, that first entry, 1, 1, is -5. Do I need to do anything else? No. They are not inverses. It did not equal the identity. I can finish it for you. If we finish it, we get -6 plus 6 is 0. And then we get -1 and -1 is -2. And then we get -3 and -2 is -5. So this is not the identity. So they're not, therefore, they're not inverses.
So to find or something. Never mind.
Okay, so now let's go about actually finding an inverse. Now, when did we say no inverse exists?
0.
If the determinant equals 0, that's right. So if we start and we do 1 over the determinant and it's 0, we can stop because there's no inverse. All right, so to find the inverse, you do 1 over the determinant, 2 minus -6. Okay? Next step, switch the main, 1, 2, negate the other. So we're switching signs. So the -2 becomes +2, the +3 becomes a -3. All right, so what is 2 minus -6? 8. So this is 1/8. I need more space. Oh, that didn't help me. Usually that is set on the big white rectangular box, which it wipes out everything I don't want. Okay, so this is 1/8. 1, 2, -3, 2. I'll go ahead and tell you, with inverses, a lot of times we have fractions. We just do. Because the formula has a fraction in it, doesn't it? So seldom does everything just turn into a nice little integer. here we're going to distribute the 1/8, do the scalar multiplication. That gives us 1/8, negative 3/8. But then we have 2/8. What does 2/8 reduce to? 1/4. 1/4, 1/4. And that's the inverse. Okay, let's do number 10. 1 over the determinant. So that is negative 5 minus negative 6. Oh, this one's going to be nice. Because my determinant is 1 over negative 1, 1 over positive 1. It's just easy. All right, so now we have to switch these two. That's not 6, that's 8. That's why y'all are all looking weird. Okay, who was making fun of the people that needed a calculator for numbers less than 5?
You.
That was me.
Awkward.
That is
That's a risk.
that's the way it should happen right there. I would call that appropriate.
That's
All right, so we switch these two, and then we negate the signs of these. Okay, so this becomes 1/3, 5 to negative 4, negative 1. All I did was simplify this part, which was negative 5 minus a negative 8, which made negative 5 plus 8, which made 1/3. So now I have to distribute the 1/3, and absolutely nothing simplifies. 5/3, negative 4/3, 2/3, negative 1/3. Okay, so once again, these two switch, these two change signs. All right. What I would like you to try to do, we're just going to skip number 11 because I didn't put fractions on your quiz. You guys hate fractions.
You right.
I know. All right, so you take a moment and you try to find the inverse for 12, 3/14.
Yeah, wedding cakes are like, that's like an exception.
My mom made her wedding.
Weddings are like the exceptions to like this stuff.
Okay, so we omitted this one. All right, first thing we have to do is find the determinant. So it's 1 over 5 minus 18.
Yay.
5 minus 18 is negative 13. Well, because the determinant of this problem is negative 5 times negative 1 minus negative 3 times negative 6. Right? Which is 5 minus 18, which is negative 13. Okay? Then, we swap, we negate.
Wait, you're recording?
I am. So we get 1/13, negative 6/13, negative 3/13, and positive 5/13.
Yes, sir.
We get a lot of fractions. Inverses just give us a lot of fractions. It's okay.
I
Yes.
asked if we were recording like 10 minutes ago.
I paused. Oh, you get a bonus point. Yes, you get a bonus point.
What?
I asked if we were recording 10
That's
minutes
not
ago.
even a math question.
All right. This one.
What?
Determinant is 1 minus 0, so it's 1. So it's 1 over 1. Switch them. Negate. So this is just 1. So the inverse doesn't look much different. It's just 1, negative 1, 0, 1. This one. The determinant is 0 minus 0, which is 0. No inverse.
See? It's a bonus point.
Okay? Alright. The back is a really good review.
Do some homework.
Okay, tomorrow though, for my sanity, I didn't give you really big things to multiply. So, there will not even be a 3 by 3 times a 3 by 3. You will not even see that. You will not. You might see some 2 by 2s
One by one.
mixed up with some 3 by 2s or 2 by 3s. That's possible. That's not too difficult. But I'm not gonna go as large as a 3 by 3 times a 3 by 3. It's gonna be kind of simple.
It's just tedious work when it gets